An object has a period of 4 seconds. What is the frequency of its motion in hertz? A, 1/16 hertz, B, 1/8 hertz, C, 1/4 hertz, D, half a hertz, or E, 2 hertz. So the thing to remember for this is that we want to relate period and frequency. So the first thing to do is remember what are the equations for period and frequency. So remember that period is the time it takes to complete one cycle. So T, represented by the total time it takes to go around, divided by the number of times you go around. We also know that the frequency is how many times you go around, or how much you do go around, given in 1 second, which is given by F is equal to N over T. Now, this question is asking us to go from period and answer a question about frequency. Now, we can pick specific values and plug them in and try and find some values that work here that will give us a valid answer for the period in terms of the frequency. Or the better way would be to take these two equations and combine them into a single equation that we can use in order to relate period and frequency in a simple and concise way. Now, there's two ways to alter around the equation for frequency that we're going to do first. The first is the more long, tedious algebra, where you have to be careful what you're doing, and the second is a simpler but a little bit more of a trickier way to do it, which in the end will be the best way to do it. You'll be able to do it a lot faster. So we'll go through each one individually. So the first one we're going to do all the algebra out. So F is equal to N over T. So the first step we're going to do to this is going to multiply both sides by T. We just want to simply change this equation around to something that will help us. So we're going to multiply both sides by T. That'll give us N is equal to the frequency times the time. If we now divide both sides by N, we're going to have 1 is equal to the frequency times the time over N. Then, given the form that we have 1 is equal to the force times the time over N, we're going to divide both sides by frequency. So multiply by 1 over F on both sides. This, in turn, will give us 1 over the frequency is equal to T over N. If we now look back to our equation for period, we see that our period is equal to T over N. So now, knowing that T over N is equal to 1 over F, we can now plug that into our equation to find that the period is equal to 1 over S. We see that frequency is the inverse of time, and the period is the inverse of the frequency. So we can also relate frequency and period in another way by multiplying and changing it to the form of frequency is 1 over the period. This here is a relation between the two equations that we're looking for. It's a concise way to go from one to the other instead of having to choose arbitrary values for the number of revolutions that occur and mixing up with your times. It's a lot easier to do it this way. So the second algebraic way to evaluate and get this equation would be to start with force is equal to F is equal to N over T, frequency is equal to the number of times you go divided by the time. Now the simpler way, instead of going through all the multiplication and division, would be to simply take the reciprocal of both sides. This is valid. It will still give you the same value. So if we did this, we would get an equation of the form of 1 over F is equal to T over N. This is the normal way that you would have done in algebra class here in step 1, where you do all the multiplication and division. And 2 here is a little bit more of an advanced way to some extent, a little bit of a trickier way, because you have to make sure you're doing it appropriately and not just doing this to every other equation that you see, where there's other parts. When you're adding something to it, you have to be careful. So in this case, it's very straightforward. We have two things on each side. You have F, and then you have N over T. so it's valid to do it in this case. That's why we're going to show it here. And this will make it a little bit easier to see the relation a little faster. So with that being said, we now have a relation that the period t is equal to 1 over f. And we also have f is equal to 1 over t. Now, the question initially asked for what is the frequency of its motion. We know that the period is 4 seconds, so by plugging this into the equation, we find that the frequency is 1 over 4 seconds, which would be 1/4 Hertz, which corresponds to answer choice C. Quarter of a Hertz, 1/4 Hertz.